So, remembering's a challenge for robots. What about memory? Well, recall we've talked about types of knowledge involved in deliberation. We've got Ron Arkin's list, which was like, hey, we want to remember spatial world knowledge. We want to remember things about objects. We want to remember things about what they look like and how to see them. Behavioral, how to act. Ego knowledge, things about ourselves and about what's around. Intentional knowledge, lots of lists of things to do. And of course, a big important type of knowledge is to be able to reuse over time, temporal reasoning, temporal knowledge, which means we have to think about memory. So what do we need to remember as a robot, and for how long? Well, we can get some insights by going back to neurophysiology. And you've heard the term short-term memory. That's a temporary memory. It's seconds long, sort of like for us in computer science. It acts like a cache. And we can mess with it as like this just holding manifold. And it can be replaced or interfered with if lots of things are going on. Now, you'll also hear something very similar to short-term memory. There's some discussion as to whether they're the same thing or slightly longer. Working memory, but it seems to be a dedicated cache that's for a particular task and sort of, around the working memory, around the work you're trying to do. Long-term memory is that permanent memory, those memories that may last for days or years, but we know that not everything in short-term memory moves to long-term memory. And we know that from all the police procedurals and how witnesses always get things wrong or something. And we're going to call that process of going from short-term to long-term memory consolidation. We know that not everything moves over. We know that short-term memory can be screwed up or interfered with by events and being overloaded and things override it. So what does that mean? Now, if we go back again, looking at the neurophysiology, the thing that might get us, the mechanisms that we may get for putting stuff in short-term memory, almost certainly not the same mechanisms that are going to get us those things consolidated and put in long-term memory. So short-term memory typically is something we associate with the neocortex, and the neocortex is taking in very different streams, the visual, the spatial, the phonological, what we're saying, and then combining them into what appears to be one memory, one declarative memory. And sometimes it does that just, you think in a matter of minutes, but maybe hours. Sometimes it takes years when we say we're still processing that memory. That in fact could be true. Now, when we think about memory consolidation, again from the robotics thing, interesting to note that mice tend to remember only high saliency events. Those are ones that really produce a strong or unusual stimulus, or there's a high reward. It kind of makes sense. Things which scare the bejesus out of you, that's a warning to pay attention to that. Remember that and figure out how you survived. Then there's the high reward is like, ooh, food, good, pretty other, yay, hubba hubba. Those types of things. Okay. Now, for a robot, certainly not thinking of hubba hubba for the robot, right? What we're thinking about now here is that how do we do that consolidation? And in people, we know that we can explicitly improve our memory consolidation by things like repetition. That's why we tell you when you're trying to remember a number, just keep repeating it over and over, and that keeps it there. And then reviewing your notes over and over before the exam so you can remember there. But it can also be implicit. And you can think of seeing that association of very bad events and things that are happening subconsciously are not being aware of it, and that can influence that consolidation and what you've remembered. But again, what kind of memories? And that's getting us back to, is it an episode? Is it learning how to replace a dishwasher? Which is a procedural thing. Is it emotion? I have memories, and I have such bad memories, I never want to do that again. Semantics, or the relationships. Okay, when we set the table, we want the knife and spoon on this side, we want the fork on that side, we want that salad fork way over there, we want the dinner stuff up there. those type of relationships can be important to remember well. So it's a long list. Now let's just change this a little bit, go for a different direction for a minute, just to see how hard it is. We don't actually really know that much about memory consolidation and what memories we need to duplicate for human reasoning abilities in robots. But a really good system for duplicating the way people think at a cognitive level is ACTAR. It's a cognitive architecture. It was extension by Anderson of Newell and Simon's work. John Laird did a lot of work on Prefamous. And so we saw, remember from strips, we're using production rules. And the good thing about ACTAR is that it can duplicate human decision making. Nice, so, but we know, they model it. But more importantly, we can predict human decision making. So that tells us that we've got some power with those models. The bad news is it's only for small domain. It can take years to identify and code all the rules. And we're not really sure where some of the natural decision making fits in and all these things. So it's not a perfect thing, but it's as good as we got. But the point is, we need to remember things. So how does ACTAR handle that? This is a nice paper from Frank Ritter's group, and his colleagues put this together. You've seen on one side, we're seeing the environment. We're seeing the cognition layer, the smart stuff. So it needs declarative memory and it needs production memory. How do we do things? What are things and what are their relationships? And then we've gotten something going on with that sensing and acting, that perceptual motor layer. Something's going on there. Well, we're somehow getting information from the environment. Pixels or symbols, clicks or key presses are going out. Speech manager, we're saying things, but the auditory manager, we're hearing stuff coming in. And then we've got all of these attentions. So production tells us where we are, what we should be looking for, what we do. And clearly, this is from a computer science, a little vague. There's a big difference between pixels and symbols and how that miraculously in just one line gets transformed from the environment to, from a raw image into a symbol, but, there. But we're seeing, look at all the things that we're trying to do with memory. So this is important to get all of this right, and we have a lot of sources and things to remember. So keep in mind, we haven't solved how to make symbols out of raw sensor data. We know there are lots of modalities and information emerge, images, sounds, actions, spatial sequences. Excuse me. We still haven't solved what goes into short-term or working memory and how that's consolidated into long-term memory. We know it's important. We do have things called long short-term memory neural networks that learn sequences. Not the same thing as short-term memory and long-term memory, but the networks do learn sequences. And there is some relationship, but not a one-to-one correspondence. And planning-oriented deliberative AI assumes that those symbols are going to be in logic. There you go.